Hello and welcome to a really short video on event-driven security using the Orca security platform. I'm Scott Van Kelken and I work for Orca Security. I have with me today Taylor Holloway. He's the CTO of Advent One. Advent One are a fantastic organisation based here in Melbourne in Australia. They provide managed services and security services to a range of customers. Orca was founded on 4 key principles. The first is coverage. We believe that all of your cloud assets should be covered with 100% visibility across all of your cloud providers. We also believe that your cloud security landscape should be secured holistically. It should be comprehensive. You should have one solution to detect all of your security risks across your entire landscape. We also believe that any solution that provides security should do so with context, rather than giving you an avalanche of alerts or giving you alerts that are disconnected and in silos. We want to have full context. We want to piece together disparate pieces of information to make the security information meaningful. We don't want to give you silos. We want to give you full context. All of these things add up to making your cloud security consumable. This means that we're giving you actionable data so that the teams that use this can make decisions faster. How do we do this? We have a unified data model. This unified data model is really important to us, and it's how we provide context. It's how we provide actionable data. We ingest metadata from the cloud control plane, from all of the cloud providers. Any CI/CD scans that you may perform get ingested into the unified data model. Our side scanning process that scans virtual machines, serverless functions, blobs and buckets, as well as containers. We also ingest findings from that process as well into our unified data model. And then lastly, we ingest any cloud event logs and audit logs that may be applicable. All of this gives us a unique ability to be able to surface just the risks that matter. So what we're going to show you today is we're going to show you a bit of a solution. One part of it is using Orca Security. The other part is using the Red Hat Ansible automation platform. Orca Security is going to do what it's good at, identifying and prioritizing security alerts within cloud-based systems with full context. Orca will also provide a single queryable source of data for all security risks. And Orca will fire events for security risks as they are found. The Red Hat Ansible automation platform will do what it's good at. It will handle multi-stage workflows. It will also provide access to the cloud platform for remediation purposes. And then lastly, the Red Hat Ansible automation platform will in fact be performing remediative actions. Using an event-driven architecture, we're going to have Orca perform a non-intrusive scan of all cloud assets and prioritize the security risks that it finds and raise alerts. What this means is that the Orca's platform will identify the risk, raise an alert. In our case, that's going to fire that alert to a webhook. This webhook for us is running in AWS as a Lambda function. That webhook consumes that alert, takes a portion of the metadata and sends that portion to the Red Hat Ansible automation platform. And then the Red Hat Ansible automation platform performs further queries against either the Orca security platform or the cloud provider or both, and then takes that remediative action. The first use case that we're going to look at is malware remediation. So without too much further preamble, I'll hand over to Taylor to walk us through this example.
So as Scott mentioned, we're going to start to have a look at some alerts and be able to respond to them. So I'm just here in the Orca console now. We can see that we've got a lot of instances of malware in our environment, which has been listed here as a compromise within Orca. Orca, the way it would sort of typically work with this is we'd have an automation set up within Orca that as this event is detected, it goes and fires the webhook to get it all started. From a remediation perspective, in the demo, obviously, we're just going to manually kick one off now. So we can see we've got an asset name called Orca Demo Malware, which is, I suppose, appropriately named. We're just going to trigger a webhook and we're going to pick our malware response. And what that's going to do is start to trigger Ansible. So when Ansible starts to kick in, we'll see a job pop up here in a moment. It's going to have a look at Orca and understand we've got a lot of instances of malware. How do we collapse those down to understand what are the assets that we need to quarantine? At that point, we're going to kick off a job to quarantine the instance. So depending on what the response needs to look like, it could be quarantining an instance and restoring that service somewhere else, whatever that needs to look like, or updating an AMI and triggering a scaling event. In this particular case, we're just going to do a really simple one where we might have an instance that we just want to quarantine it and stop it connecting to other systems in our network. So we can see that the response job is kicked off and now the quarantine one has started. So the first thing we're going to want to have a look at is what Orca's told us what instance ID and what region it's in. And it's going to go and create a security group with no rules and assign it to that instance, so it won't be able to connect to the internet and so on. So if we have a look at the malware instance that we've got sat here and look at its security group rules, we'll see that it's created one, a quarantine security group, which is basically sending all the traffic to localhost so it's not able to communicate in or out. So that's really the first thing that we wanted to step through is how do we get an event in Orca and have it immediately fixed? We don't go and try and blow away and stop everything. We just pick the system that has the alert that matches the criteria that we've set. We can be very granular in terms of how we query the systems that we want to take action against and then be able to have it quite quickly.
The next example that we're going to look at today as part of our Orca security and Red Hat Ansible automation platform remediation solution is vulnerability remediation. This is a little bit different from the malware remediation that you just saw. I'll hand over to Taylor.
All right, so I'm back here in the Orca console again. And what we've found here is that we've got a couple of systems that match a criteria. So it could be something that's internet facing that has access to a system with PII, or PII may exist on that system. And we can see that its kernel needs patching and SSHD needs patching. So there's two separate alerts for vulnerabilities that sit above a 7 that we're going to want to be able to take action and do something about. In this particular example, we've got an approval process in here as well, where we might not want to go do this patching in the middle of the day. We might want to have it happen at an appropriate time, and we can approve for that patching to take place at the most appropriate time. So the first thing we'll do is click over on integrations, and we'll send this to a webhook. So this is automatically going to be kicked off when the event is detected. However, given we're doing a demo, we'll just kick it off manually now to look at a vulnerability response. So we can see that Orca alert was sent to our Ansible vulnerability response webhook. If we click over to Ansible automation platform, we can click on jobs, and we will see in a moment, it'll pop up with a response to a vulnerability event from Orca. So with any luck, that'll just kick off now. Here we go. So we can see that this has started. And what it's going to do is look at the information that's been passed to it from the Lambda function that actually triggers this. We don't have Ansible automation platform exposed to the internet. If you did, you could have Orca trigger it directly. However, we've got an API gateway and a Lambda function sitting in the middle, where we can pass a little bit more information from Orca to Ansible as part of this whole sort of process. So we can see our workflow to do some patching is kicked off. So if we click over on workflow approvals, we'll see that we've got one here. Do we approve the patching? Yes, we do. And we go back to jobs, and we'll now start to see our patching process kick off. So we've got a job here doing an inventory sync. So we've got a dynamic inventory set up to our AWS environment. So it's going to go grab the latest set of instances that we have, and it's going to start running through that patching workflow. One thing, if we click on the job that's doing the patching, that's important to look at, is it's not going to just go and try and patch the entire inventory. Orca knows exactly what the asset is. So in this case, it's Orca demo and patching, and also we could pass it exactly the packages that need to be patched rather than just doing a DNF update and patching the whole thing. But if we compare the two, we've got Orca demo patching as the one here that needs kernel and SSH patched, and that's what the limit's been set to when it runs. So we can see here our Ansible playbook's running and patching the instance, and away it goes. And we can see now that patching's been completed. We go back to jobs, and we can see our workflows run through and everything's done. So just to wrap up on what happened here, Orca detected that a system based on a certain criteria needed patching, and we wanted to do automatic remediation. Based on that criteria, Orca triggered Ansible automation platform. Ansible then kicked off a workflow to be able to remediate the problem and apply the relevant patches. There was an approval process in there as well. So rather than just having it all happen with no human intervention whatsoever, which is certainly possible, we put a human approval process in there just as part of the workflow to kind of demonstrate how this can be done.